Am I audible and am I visible to you? Can you give me a thumbs up if I'm audible and I'm visible to you? Hello, Mayur. Hello, Prashad. Hello, Akbar. Hi, Soumya. Hi, Vamsi Krishna. Hi, everybody. Thanks for joining. And what we are going to do is I'm going to share my screen in a bit. Just give me a moment. I'm just seeing if everything is in order. So this is going to be a very, very interesting session, guys. Stay tuned. And we will learn a lot of things today, okay? And very important topic, basically, not something which is not important, okay? Very important topic. And it's a three-part series, basically. So stay tuned. What I'm going to do is I'm going to share my note first and we will discuss few things, okay? So let me share my screen. Share my screen. Application window only for now. Are you able to see my note? Can you give me a thumbs up, a blank note? Are you able to see a blank note on the screen? Now you will be able to see the YouTube, but just write blank note visible, okay? So that I know blank note is visible. And please give a thumbs up to this video, guys, so that more people can get notification and they can join as well. Just write me BNV, blank not visible. That's it. Nothing else I want, okay? So I'll start writing. I'm assuming it's visible. And welcome to this session, guys. And as I have been announcing about this session since some time, this session is all about AI engineering, and it will be a series of 3 live sessions. Okay, so I'm going to write here AI engineering workshop. This is not a tutorial, guys. This is a workshop. Okay, and what is the difference between a tutorial and a workshop? You know, so this is part 1. Okay, this is part 1. We are going to do part 2 and part 3 next 2 weekends. So what is why I have chosen this topic? Let me go to chat once and see. Yeah, note is visible. Okay, fine. So what we are going to do is we are going to first of all learn why we are trying to learn AI engineering. Okay, why we are trying to learn AI engineering. That is the first part. Why AI engineering? Why not anything else? Second is, and important to understand, how generative AI project is built and deployed. Okay, how basically Gen AI project is, how Gen AI project is basically developed or deployed, whatever you call it. That is second part we will understand. And then we are going to do a end-to-end project right now. Okay, end-to-end project. And in doing this project, right, we are going to understand various components of Gen AI that you should know, basically. Various components of Gen AI, various components of LLM engineering that you should know. Now, let me hide this. So one part is why AI engineering we are learning and how AI engineers is different from traditional data scientists or traditional programming. Can you tell me in comment, please, how AI engineers are different from traditional data scientists and traditional, basically, programmers? And why this is one of the most sought after skill in the market today. You call it AI engineering or you call it LLM engineering, whatever you call it, one of the most sought after skill in the market today. Why? What is your view? What is your view on this? So meanwhile you are thinking, I'll just start writing here. An AI engineer, an AI engineer, okay, wears two hats together. Two hats together. Okay. And hat one is basically software engineering. Software engineering. And hat two is basically data scientists. Data scientist. Now, every time we discuss of AI engineers, we talk of scarcity in the market. And reason is very simple, guys. Somebody who has a software engineering background, very high possibility that that person might not understand what is the meaning of model evaluation. And somebody who has a data science background, that person, there is a good possibility that that person will not understand how to scale the application in production, how to do the proper configuration, how to do the monitoring, and how to build a scalable solution that can answer the business question, or what are the good practices for that. Okay, these are rare to find skill, not impossible to get, but rare to find skill. And hence, if you can command these two skills together, right, you are going to demand premium salary in the market, get premium salary in the market. Okay. So I'll not complicate this further, and we will simply move into, I'm not sure if you have watched my one last video that I had created. There was a video I created just 2 days back. Let me share my entire screen. Just give me a moment. I was sharing a window. I'll stop that and share entire screen. Okay. Okay. So I'm not sure if you have seen my video on RAG that I created like last week only, this Tuesday only. And this is building RAG from scratch. This is one video I created 5 days back. And in this video, I have explained you few things about how can you build a RAG. I mean, if you have not watched, go and watch this video, but this is not a prerequisite for today's course. But be it a RAG, be it a agent, or be it a, any generative AI application, right? What are the important steps in, forget generative AI, forget RAG, forget agents. Just tell me, what are two critical parts of any AI application? So I'm talking about machine learning, deep learning, anything. Okay. AI application, any AI application has two critical parts. What are these two critical parts? Can you think and let me know? What are two critical parts of any AI application, or two critical areas of any AI application? Can you let me know? Okay. So one part is, you can comment later, but I'll just continue. Maybe you are little lagging behind my timing basically. So you can comment there, but I'll just write here. One important part of any AI application is called training. Okay, training. And another important part of any AI application is inference. Correct? Training and inference. Inference means when you are using the application. Training means when you are building, preparing the application. One thing you need to understand here is, since the time generative AI has come, okay, this training has changed little bit. If you are an AI practitioner, or if you are into machine learning, or if you are into deep learning since some time, you will know that in the previous world, we used to do our own training, which means our data, our basically we will take one algorithm and we will train it from the scratch, and then we will get the model, and that model we will use in inference. But now, if we talk of generative AI application, this training landscape has changed because you are not training your model from the scratch. What you are doing is you are taking a frontier model, you are taking a already trained model and doing something on top of that. What is that something? That something could be prompt engineering, that something could be multiple ways of writing prompt, developing a RAG, building an agentic AI system. But the landscape of this training has changed. That is what key point I'm trying to make here. Agree? Just these are very, very conceptual things, okay? This is how things are changing in the world of AI now. So just drop a comment. Yes, you are agreeing with what I'm saying. Inference more or less remains same. The meaning of inference is there is a model, trained model. I take the data and I will make the prediction or inference, whatever it is, and I'll do something in between. So in the previous world also, I might be doing some scaling, I might be doing some pre-processing. In today's world also, in Gen AI world also, I'll do something. So inference has not changed much, but training has changed a lot. I will take an example of RAG and try to tell you how the inference will look like and how the training will look like. Sometimes this training we also call as offline process. Offline process. And sometimes this inference we can call as online process. Don't bother about continuous retraining, etc. for now. Just in generic sense, offline you do something and then this happens online. Okay. If you have watched my previous video of RAG here, this one, right? If you have not watched, later you can watch, but I will just explain you what is happening in a typical RAG application. In this video, I explained about a triangle. Okay. I said you, this is a RAG triangle. How the RAG triangle looks like if I take RAG as an example. If this is a RAG triangle, okay, what will happen is at one end there is user, at this end there is knowledge base, and at this end there is large language model. Fine. User will come, fire a query. It will go and search for relevant context in knowledge base. Knowledge base will take user's query, give relevant context, pass it to the LLM. LLM will take everything, pass the response back to the user. This triangle can make you understand how RAG works typically. There are many things inside, obviously, but this is what is happening. At what time? Training time or inference time? At inference time. Okay, this is your inference pipeline, not the training pipeline. So, how your training pipeline is slightly different. Training pipeline in a typical RAG will look something like this. You will have some data. Please pay attention here. This is important. You will have some data and you will create some chunks. Chunks means parts of the data. Okay. From the chunks, you will create vectors because you want to store that in a knowledge base. And then you will put that in a DB. In our case, vector database. Data, chunks, vectors, and then you put it to the database. This is a training process, offline process. Don't confuse. Okay. And what you will do at the inference time, user will come, take a question. You will take it and you will generate embedding. Embedding means basically vectors in this case. Then what you will do is you will do the retrieval. Retrieval from where? Retrieval from knowledge source. So I'm talking about this line here. Okay. This line here. You are hitting the knowledge base. So you will do retrieve and then you will do prompting. Prompting means context preparation. And then you will do LLM part or generation part. And then you will do return. Return means return to the user. Okay. So this is your inference time flow or workflow. Why we are understanding these workflows in proper way is basically that is how you will arrange your code. Okay. That is how you will arrange your code. Without this, you don't know how to arrange your code. So you have to understand what is my online process, what is my offline process, and if I'm building a RAG project, then how do I arrange my scripts? Clear up to here? Everything is not online and everything is not offline. The way I will build my application will depend on these two flows if I'm talking of a RAG application. Fine. What I'm going to build now in front of you is a RAG application. And let me try to show you how that application will look like. This is the UI of the application. And the same application, what we will do is we will keep improving in our upcoming sessions. But today I'm building the first version of the application, which is baseline RAG end-to-end flow with all the important components, all the codes arranged in how it should be arranged in a production environment. So the name of the application is ML Research Assistant. What is the job of this? Ask a question about machine learning deep learning. The assistant will search archive style papers and answer using retrieved context. If I go here, I think I have closed the application. So let me first go to cursor and start the application. So I'm not sure if you are using cursor for your work, but I'm using cursor nowadays because this is AI assisted programming basically. Okay. So this is similar to Visual Studio Code, but since it is AI assisted, so I just use this. Okay. I will give you this code or this entire project through GitHub. I have not uploaded in GitHub. I will upload it and give it to you. Maybe during the session only I'll give you. But once you have the code, what you need to do is just whatever steps I'm running, just see that you will be able to run the project. And then obviously we will discuss what these files are doing. Okay. Most important part to understand for an LLM engineer is how do you build your entire pipeline? And that is what I'm going to discuss in detail. But first, let's see the code. Okay. So when you have the code using git clone, I'll give you the git clone ID basically. You can do a git clone, have it in your local, and then go to this path here. Okay. ML Research Assistant, CD ML Research Assistant. Go there and then run UV sync. You know what is UV sync? UV sync is basically a faster and efficient way of managing your environments and basically something similar to .env, but it is very fast. Okay, so I'm using UV sync, and then the first thing I'm going to do is I'm going to do UV run -m scripts, and inside scripts I have a file called build index. Okay, let me run this. Okay, relative modules not supported. UV m scripts. Okay, scripts dot build index.py. Okay, what this will do is this will build my index. So this is the offline process that I'm trying to do. You remember I explained you two things here. One is called training or preparation. So training may not be a too proper word for this. You can just think of this as training or prep. Okay. So the script I'm running now, what it will do is, it will do these four things. It will take the data, it will create the chunks, it will create the embeddings, and it will store in the Weaviate Cloud vector database. Again, I will refer my last video. If you have not watched, you should watch, that will help you. Here I have explained you how to create a Weaviate Cloud account and load data from your local. Here I have explained you that, okay? But don't worry, I'll explain your code as well now. There is some error coming. No. Error while building. Try using script build index. Script build index. Okay. It is taking it as a module basically. Okay. So let me see if this runs. Okay. So what this part will do, this will take the data, create chunks, create vectors, and store that in a database. One command, it will do everything. And that is how it will, you create the pipelines. Okay. We will discuss the pipeline in detail. Don't get scared now. Okay. We will discuss the pipeline in detail. I just want to show you the application. If you see here, something is happening here. Okay. Collection paper chunk already exists. Collection is basically a higher level, you can say, database in terms of vector DB where I'm storing my data. Loading dataset. So dataset is getting loaded using Hugging Face cache. So some data is there in my cache which it is using. First 5 papers it's taking from the ML research papers. Loading, it is generating 105 chunks. I'll tell you why 105 chunks only. And then embedding model. This model I'm using for embedding. And then indexing those chunks in a batch of 32 and then storing it. You see how many things are happening here? All these things are happening here. Data it's pulling. Okay, it is creating chunks, it is creating vectors, and it is pushing in DB through one command. And that is how you build production grade applications. Okay, I will explain you this process, don't worry. But first, let this happen. Meanwhile, what we will do is it will take some time because it is creating the index and loading, but not that much time also because I have just limited the number of papers to 5 for demo purpose. Are you enjoying the session so far, guys? Just tell me yes in the comment so that I know you are enjoying the session. First, we will see the application, the front end. We will get a feel of what it does, and then we will build it. Okay, step by step. So if you see here, my indexing is completed. Fine, my indexing is completed. And now what I'm going to do is I'm going to try to run the UI. UV run Python -m stream streamlit run app UI. Okay, so you will see that one UI is getting launched here. And in this UI, I'm going to ask some questions. So let me close this unnecessary sessions. I was trying to figure out the Zoom problem, guys. It was a big problem. It was not working how I expected it to work. Then I need to do many things. So I was late for the session. Apologies for that. So you can see here, we can ask anything about basically 5 papers it has taken from the archive. So we can ask about that. So what is a variational inference? For example, if I ask what RAG should do, RAG should go and hit and it should take some chunks and it will tell. For example, now it's saying I'm not sure. Okay. And if I ask what is supernova, you will see that it is giving me answer. I'll tell you why this is happening. But first, you see that in the chunk, it is giving me a paper ID. It is giving me token ranges, which it is taking as a chunk. Okay. If you don't know what is a chunk, I'm going to tell you now. Don't worry, but it is retrieving chunk 1, chunk 2, chunk 3, okay, chunk 4 and chunk 5 because I have asked for 5 chunks to show here. In session 2, we will improve this retrieval, but for now, let's understand how this chunking is working and how these things are working. Okay. And for that, you need to understand what are the important components of any generative AI project. Very, very critical part of the session today. And think like this is your guidance for the interview. Okay. Important components of any Gen AI. In this case, I'm building a RAG, so it may be slightly RAG flavored. Okay. So let's see one by one, guys. First component of any data project will be data. Correct? First component of any data project will be data. And this data is nothing but your knowledge base. Knowledge base in our RAG application. In our RAG application, the knowledge base is nothing but ML research papers, which I am taking from Hugging Face. Okay. And if I go in my code base, right, I will explain you everything. Let's start one by one. If you go inside app and if you go inside data, then you will see something similar happening there. Let me explain you. If you go inside app, so this is app. Let me minimize so that it's easy for you. If you go inside app and if you go inside data, you will see load archive.py. Okay. It's a simple script to understand, but the key thing here is how do you create the entire pipeline? Okay. These are some of the pipeline, basically packages that I will need. And this is the main function, load archive paper. What it will do? It will load a subset of archive portion of scientific paper dataset, returns a list of dict with ID, title, abstract, and article. dsconf I am taking from config.dataset. Now this is how you build production grade applications. You write all your configuration things in config.py. Where is config.py? It is here. If you go here, you will see that there is a data config class. And in this data config class, I am saying Hugging Face name and Hugging Face config and max papers. If you want to fetch 50 papers, you make it 50. If you want to fetch 500 papers, you make it 500. But for demo purpose, I am fetching 5 papers only. HF name, HF config, and max papers all will be used here. So you can see here HF name, HF config, load dataset, HF name, HF config. Which part we want? The training part. Max papers getting used here. For I in range of max papers, give me ID, title, abstract, articles, return papers. As simple as that. What we are doing here? We are fetching our data. That's it. Okay. And to fetch our data, we are taking the configuration from where? Config.py, this file. Okay. The first part here. All the configuration will be taken from config.py only. Are you with me till here? Any questions till here? I'll take a pause. Any questions till here? Nothing? Okay. So I'll move forward. So the first part is knowledge base, app data. That part we just saw how we are doing in our code. You know what is the second part? The second part is since we are working with text data, basically generative AI application, so we will need to do indexing and vectorization or embedding, whatever you call it, vectorization. Okay. And this part is happening in our code where inside app, inside ingestion.py, basically, there will be a ingestion and there will be a ingestion folder, and inside ingestion folder, there will be chunking.py, and you will find some more things here like index.py, weaviate.py. Okay, those things we will find. So let's see what is there inside ingestion. So indexing and vectorization both are happening inside ingestion. So go inside ingestion, and you will see that here chunking.py is there. What is happening in chunking.py? Again, we are taking from config, split text into tokens. This is basically normal thing. This is returning token. This chunk paper is important. Again, you see config is being taken from config.py. Okay. Tokens is getting created. Okay. And then chunk size token, it is taking again from config. Basically, you give the size of the token, chunk size, and then it is creating the tokens and chunks. And what it will do is it will just in a variable chunk, it will append all the chunks. Now, to make you simply understand what is a chunk, It's nothing but if I say here, hi, I am Aman, okay, a data scientist and AI educator. So let's say this is my complete document. A chunk is nothing but a subset of this. For example, this could be from here to here. This could be first chunk. From here to here, this could be a second chunk, and so on and so forth. So in our entire knowledge base, right? In our entire knowledge base, we will take the documents and we will create the chunks out of it. First chunk, second chunk, third chunk, and these chunks we will store. We will store where? We will store in the vector database. So what is happening here is basically those chunks are getting created. And then this function is getting called all chunks dot expand chunk paper. So we will get all chunks from this chunking. Once you have chunk, then what you are going to do? So see this flow here. You have data, you have chunks. Your next job is you create vectors and you store in vector DB, correct? So you come here, index Weaviate. What you are going to do, you are going to create a Weaviate connection. Again, I have shown this in detail in this video. How do you create Weaviate connection and how do you store in Weaviate Cloud data? But let's see one more time. Basically, Weaviate is a cloud, Weaviate is a vector DB. There you go and store that. For example, this is my Weaviate Cloud. Okay. And in this cloud, I have a collection with name paper chunk. See this carefully, guys. Paper chunk is my collection and this part is my one chunk. Okay. This part is the abstract of the paper and there will be a paper ID also. You see here paper ID is 14. So start token 0 to end token 300, paper ID 14. This is the chunk. Now you understand what is a chunk? You understand what is a chunk now, right? For this document, token number 0 to token number 300, we are calling it a chunk. Just like I gave you example here. Token number 0 to token number 300, one chunk. Okay. And then for the same 14 number document, for the same number 14 document, this is 29 number document. So this is paper ID 2. Okay. This is paper ID 3, paper ID 14. Okay. For the paper ID 14, start token 6750, 7050. That is stored here. So that is another chunk. So basically you are breaking your papers into chunks, and you are storing in this paper chunk vector database. How we are doing that? Chunk we have previously only created. Okay. Now we are creating connection to Weaviate client here. We are ensuring that schema exists, basically that collection, etc. And then these are the properties. So if you see paper ID, title, abstract, chunk text, start token, in token. See here, properties, chunk text, start token, in token, paper ID, title, and abstract. These are the properties which we are simply taking and pushing. Where from we are taking these properties? Again, we are taking this, as you can see here, data type.txt, and this will be coming from where? Configure property data type. So basically this is a function in your schema, and in this function we will push the data now. Index chunks, client, and if you see properties, so from the chunk we are taking and pushing it. Okay. From the chunk. Where from chunk is coming? From the previous basically part. Okay. From the previous chunking.py. So on the top they would have imported. We would have imported. So app.config, list, configuration, web sentence transformer, somewhere that input will be there, or the reference to that module will be there. So chunking, or in the pipeline when we will call it, right? Then we will refer when we run the entire process. Okay. So these two things are for your basically chunking and pushing data in Weaviate. As you can see, when I ran, the data got pushed into the Weaviate. Okay. So this part is from here to here is indexing, vectorization, app ingestion, chunking.py, index.py, weaviate.py, and then build index I want to show you. Chunking.py, index.py, and there will be a inside scripts. If you remember, the first thing I ran is build index.py. So in build index, right, what we are doing is we are loading all our functions. So if you see, we are from this one, load archive paper, from chunking, chunk papers, from here index, get Weaviate, everything basically from previous three scripts we are taking. Okay, index, Weaviate, and chunking, whatever we are doing, we are taking here, and then we are just calling it one by one. In main function, get Weaviate client, ensure schema first, then load archive paper, then chunk paper, then index chunk. Simple. This is how you build modular programming. And this ends your training part or preparation part basically. This ends your preparation part. So you finished all four steps. You imported data, you created chunks, you created vectors, and you pushed in DB. All those things you arranged strict how it should be done in a production setup, inside ingestion, inside data, and then inside scripts, you are calling that one by one. And then when you call the main function, everything gets inserted. If you remember, the first command I ran is build index.py, and then index was built. What is the meaning of index getting built? Nothing but the chunks are stored in vector database. This is your second part of a basically RAG project. Okay. What is the third part of a RAG project? Third part of a RAG project is retrieval. And this happens at what time? This happens in when you are using the RAG. Retrieval. Okay. And for this retrieval, what should happen? What should happen is your matching should happen. Okay. This is basically the RAG functionality. Matching should happen. And this matching is happening in our case, in our app basically. If you go inside app, if you go inside RAG, and if you go inside retriever.py, okay, let's see this file. I'll explain you now. Then you will know that how the retrieving is happening. Again, modular programming, easy to understand. Go inside RAG and go inside retriever.py. You will see that it's a very simple file of matching. Matching what? Matching vectors. So here you have some data stored, right? What we will do, we will simply take our data, create vectors, and match with these vectors. That's it. So if you see here, I'm taking a sentence transformer for embedding. See here for embedding. Okay. What retrieve function is doing? It is encoding my query. Then it is doing near vector. Near vector means matching with the data in the RAG. And then whichever matches, right, that it's returning paper ID, title, abstract, chunk, text, token, and token score. So this file is again very simple to understand. You are having a embedder basically to create vectors. You will hit the Weaviate because in Weaviate your data is stored, and then through this function, right, through def retrieve, you are simply saying give me the near vector. How many near vectors? 5. Give me the 5 near vectors, and that's it. You just take those chunks and return those chunks. So this is about retrieval part, retriever.py. Okay. I'm sure you would have never seen anyone explaining RAG like this. Okay. We are going step by step. We are understanding what is happening where. So question comes from the user, then embedding gets created, and then the retrieving happens. These three things is happening here. If you see again that file, We will start from user query, class retriever. Okay. Weaviate, this one. When we call this, like when we use this method, right? Self query, which is the user query. Okay. We will call with user query, and then we will go and search in the database. That is what is happening here. This is your retriever part. Now which part will come? Now which part will come in a traditional RAG or typical generative AI project? Now the part will come will be LLM part. Okay, LLM part. LLM part. And what this LLM part will do? It will simply take the context that you have done from the matching, and it will just try to prepare the response. So if you go inside again app, and if you go inside RAG, and if you go inside LLM client, you will see that whatever I explained you is happening here. Go here inside RAG, inside LLM client. From typing, these are the package config. Again, we need to import. So in config, as I showed you in the beginning, right? There are many things happening in where there are many things in config. Everything is a configuration for these things. Okay. So for example, now I'm in LLM config. So I will need a model, right? So LLM provider, OpenAI, LLM model, GPT-4o mini. Temperature I can change from here. Max token I can change from here. So basically all the configuration I'm writing in config.py file here. And I will repeat it again. This is how you build production grade applications. You don't build production grade applications in Notepad. So all your LLM related things here. Then you go to LLM client. And what will happen here is very simple to understand. These are model specific parameters. We are taking OpenAI. We are taking key from the environment variable. And then we are hitting this URL api.openai.com, generating the answer with context. Where from context will come? Two things will go, query and context. Context where from it will come? Context will come from previous step. Okay, the matching step. URL helpful system prompt, the answer based on provided context. If answer is not in the context, say you are not sure. User prompt, you give query, you give context. Very simple. And in the payload, you prepare the JSON and you just send it. You just hit basically OpenAI server, and then you get the response. So I'm not using OpenAI.completion. I'm using this method, and why I'm using it, you will know when we move to the next sessions. Okay. So here, what we will get in the output, we will get the response from the model. That's it. We will get the enhanced response from the model. So we are at which step now? We are at prompt step. Okay. And then LLM step. So we have seen that. Now the returning step. How the returning step will work. In your LLM, what will happen is all these things need to be called through a pipeline basically. So you saw that, right? When we are discussing this question, embedding, retrieve, prompt, LLM, return, all these things will be called through a pipeline because it's a one shot run, right? So I'm going to write here pipeline. I'm going to write here pipeline. Okay. And what is the use of pipeline? As I told you, glue everything together. Glue everything. Okay. And where is your pipeline script? App rag pipeline.py. And what is there in the pipeline? What will be there, you think, in the pipeline? Nothing but all these steps stitched together. So question to embed to retrieve to prompt to LLM. That's it. Go to pipeline. You will see that it is importing LLM client and retriever. Both these things are important. In retriever, you are just retrieving. In LLM client, you are getting the response, right? So RAG result, it will take RAG pipeline, retriever LLM client. It will simply say answer query. Okay. And in answer query, it will say just Retriever retrieve, LLM generate answer. That's it. RAG result will be query answer context. So this is what you are able to see in the front end. Query answer context. This is your query. This is your answer. And context we are not printing, but chunks we are printing. Okay. So this is your pipeline to glue basically these things together. Return, it will return. But now we need to run this pipeline also, right? So different ways to run this pipeline basically. And the way I'm taking here is UI way. So when I click on this button, right, search and answer, then pipeline runs and I'm able to get the response. So let me show you that as well. So the next part of my pipeline will be first of all, let's write here. Once the pipeline is done, then you will not do a manual run of the pipeline, or you will not do a user will not come to the command line, right? User will come to the UI. So in UI, we will call the pipeline, basically inference pipeline. And where is the script? The script is in pipeline.py. So no, pipeline.py is gluing everything. The script is in Streamlit. Okay. So this is basically Streamlit.py. Streamlit.py is inside my UI folder. So I will show you that. UI. Streamlit app. This is the one. Okay. So if pipeline not in there, then start pipeline. Basically the first time render. This is your UI. What you will see in the UI. ML research assistant that you could see on the front end. The name, page title, basically this one, ML research assistant. This is title. You can see. Ask a question. This you can see. Then query. We are preparing the user query. We are stripping and we are using this to, you see here, pipeline dot answer query. Now what was there in answer query? Do you remember? Come here and see pipeline dot answer query, and this takes query. This takes how many results you want, and that is exactly what is happening. Pipeline dot answer query it is taking. Query is what you are giving in the input. Top k 5 means 5 things it will bring, and then it will give you the result. And now once the result comes, right, you want to show it to you want to show the chunks, you want to show whatever you want to show, that is your choice. Okay. So here we are just basically taking the, see, retrieved chunks is printing, and then we are just taking the chunks and we are trying to print it. So if you see a CTX, right, for ICTX in result.context. So from the context, we will take that. Okay. So result is where you are getting the response. See here, result is where you are getting the response. From this result, you can take the context, and that context also you can use it in whatever way you want to use it. For example, here chunk we are taking ctx.title, we are taking ctx.paper, we are taking ctx.start token, we are taking end token. So all these things that you are seeing here, basically, see here, paper ID, token range. Okay. So token range, start token, end token, score, and then chunk text. So everywhere you will see that. So 5 most matching chunks are here. So basically 5 is our result. Run a query to see retrieved chunks here, and this is main. So when you call the main, then basically all the things get called one by one. So this is the flow of your RAG pipeline. The above two are written in black color, and the reason of that is this is only training. This one and this one. And below 4 are at written in other color. So inference. This one, this one, this one, this one. So this is our RAG now, and it is working fine. And if you ask something which it does not know, then it will say, I don't know. For example, these are my papers, right? So ask something which is not there in those papers. So, for example, what is cricket? It should say, I don't know. I'm not sure. Okay. How we will know that which answers it will give? If I go to Weaviate Cloud, I can see the chunks. Okay. And in the chunks, I can ask something relevant. Okay. So for example, go to any chunk text. What is Brock dataset? Let's ask. What is this one? Brock datasets, whatever it is. What is Brock dataset? It should give me something. Yeah, data acquired by part of something. The dataset consists of whatever it is, and it is checking from chunk 1. Chunk 1 is which paper? Paper number 23. So let's go here. Paper number 23. Paper number 32. Okay. Paper number 32. Why it is saying paper number? Did I take from other place? Paper number. One moment. Chunk 1, paper number 32, 0 to 300. Chunk 2, 32, 52, 52, 550. View collection details. I basically want to see where from it is fetching, because that is where our problem lies. Okay. Paper chunk. Large number of supernova. Let me ask supernova. Okay. Have been discovered and many more will be found. Once discovered, further study of possible astronomical knowledge of SN type. Current classification. Further study of a supernova and its type. Astronomical tool. So let me ask what is needed to study about supernova. Okay. Let me ask this. What is needed to study about supernova? To study supernova, several key components. Paper ID 14, token range 0 to 300. Paper ID 14, 0 to 300. Yeah, this is how what I want to see. So it is taking from this chunk basically. Okay. And if this is the first attempt to model the kinematics of CME launch and result. The model contains 14 free parameters. First, tell me about first attempt to model the kinematics. Let me ask. Tell me about first attempt to model the kinematics. Okay. The context provided does not specific information, therefore I'm not sure. So what is happening here is our chunking is working fine in some cases and chunking is not working fine in some other cases. Okay. The reason being the chunking strategy that we have used is uh, not that sufficient or high end or whatever you call it. So that there are different things we can do in RAG. This is a complete flow of one complete flow of RAG. Okay. But the thing is, how do you make it better? And that is what we are going to do in our upcoming sessions. What is missing here, first of all? What is missing here? Who can tell me? There is a question. RAG is used to avoid hallucination for sure, but above question about MCP. What is the question? Data is structure, data chunk, overlap, indexing. I am not getting your query. Can you write one more time, Prashant? Because I need to scroll a lot on the chat. So you can write one more time. That will be great. Okay. So this is our RAG, and there are some problems with this RAG. Obviously, it is working, but if I have to make it better, basically, then what I can do? The one part that I have not written here in this flow is called deployment. Okay, so let me write here deployment. Deployment. This is the final piece of the this flow that we are learning now. Okay. Deployment is another component that we should cover, and that also we will cover in upcoming session. But I'll just explain you what's missing in this current project. What is missing in current RAG? What is missing in current RAG? One, evaluation is not there. Okay. So how do you know that your model is good, not good? What is the performance? Are your chunks good or not good? Okay. That is evaluation. Second is chunking strategy. So normally we don't leave it to the model to decide how to chunk, and basically we take control of chunking. Okay. And that is what is important, and that is what we should do. Chunking strategy is critical, evaluation is critical, and we can also do different kinds of embedding. So for example, experiment with embedding. These are the things which you normally do or you must do in a production grade applications. Once you are happy with your model, once you are fine with your model, then you should basically put that in a version control or Git or somewhere. And then just to keep it simple, I'm writing code control, CI/CD, etc. This is one component. And the next component is deployment. Wherever you are deploying in cloud or you are deploying in some server, wherever you are deploying this. So what my plan is, next Sunday when we meet, right, we will cover these. After that, when we meet, we will cover these. So there are two more sessions, right? 7th of December, 7:30 p.m. IST. 7 December only, right? Let me double check. Next Sunday, 7 December, right? Whenever is the next Sunday, basically. Yeah, 7th and 14th. Okay. So 7 December when we meet, we will build first three. 14th when we meet, we will build bottom two. Now your questions, please. 14th December when we meet, same place we can meet. There are few things in the code which I will explain you. So RAG, what? So one by one, let's quickly see which part is doing what. Okay, let's quickly see. Virtual environment, all of you are aware of, I am assuming. But if you are not aware of, virtual environment is basically a place inside your installation of Python where you go and prepare an environment for one particular project to keep it separate from other environments and to keep it clean. Okay. There are two ways in which virtual environments can be used. One is in Python, you can create. What I have done in my case is I have done UV sync. As I was telling you in the beginning, UV sync is a faster and cleaner way of doing it. So if you remember in the beginning, I did UV sync. What this UV sync will do is it will go and read this file, pyproject.toml. Okay. You see this file here, pyproject.toml. It will see this, it will see this, it will see this, and it will see the dependencies. And it will create a virtual environment for me. When I run UV sync, right? You will see it is telling me resolved 111 package, audited 89 package. So basically it is ensuring that my virtual environment is fine. And then using UV, I'm running all the commands. How do you normally run virtual environment? You normally create a virtual environment, then you activate it. Inside that you do installation. Inside that you run your code. Here I'm doing UV sync, which is taking care of my virtual environment using pyproject.toml, and I'm running using UV. Okay. Read me.md is about project. Requirement.txt is still there if somebody wants to use virtual environment. UV lock is there, which is created by UV. Don't worry about it. Okay, so this is about when you run UV sync, it will get created. Have this script is not needed. Show processed papers. I'll just delete it. So inside build index, we are just building everything and uploading, and rest of the things are inside app. Okay, inside app, inside data, you are loading the data. Inside ingestion, you are ingesting. Inside RAG, you are retrieving, and inside RAG only pipeline is also there, and inside UI, you are just seeing that. HF cache is Hugging Face cache, so don't worry about that. When you download from Hugging Face, it will get created. In .env, my personal codes are there. My personal API keys are there. What I will do is I will remove this. I will remove my own keys. Okay. And I will upload it to GitHub. So what I will do, I will go to my GitHub. I will go to my GitHub, Unfold Data Science Outside. I will create a new project here. In this project, I will upload all the files. But remember, in .env, I will remove my key. I will remove my Weaviate URL. I'll remove my Weaviate key model, everything. So you need to give that. How to give that, I have shown you in this video. In this video, I have shown you how to prepare your Weaviate URL, Weaviate key, etc. OpenAI key, most of you would already be knowing. So just, update.env is what I'm saying. I'll almost remove everything from .env and then upload it to GitHub and share the link with you. Okay. Share the link means you can come to Unfold Data Science and you'll be able to see that. Yeah, evaluation part is pending, that I told you. And hyperparameter tuning is basically whatever we are giving in config, what works good for well, okay? Good for us. That's what I mean to say. Whatever we are giving in config.py, right? In that config, what is working good for us is our parameters, right? So these parameters we can try with different parameters. Explain the superseding of cursor ID against Google anti-gravity. I'm going to create a detailed video on this topic. I will touch it there, okay? We need to do hyperparameter tuning. Yes, hyperparameter tuning we will do, and we will do using config and basically a combination of parameters. Okay, one more thing before we forget, guys. I am basically working with Super Data Science on launch of a generative AI brand new course. Okay, so that course I'm just going to show you now. Not generative AI, sorry, AI engineering bootcamp. Okay, so in AI engineering bootcamp with global certification is what we are working together on. And you can just come to this page. I'll give you the link and you can read about it. And if interested, you can pay the token and you can talk to me. Okay. With that in mind, if you have any doubts, guys, you can just post it below this video and I will see you in session 2. Meanwhile, take the code, run it. If you face any problems, we can discuss in the next session or in the comment. Don't worry about it. Just keep watching. this video, try running, try changing parameters, try working with prompts, okay, and see if you are able to generate something more interesting, something more better. And check out this bootcamp page. You can talk to me one-on-one after paying 5,000 deposit, and then we can discuss about bootcamp, okay? So this bootcamp is launching in January. You can talk to me about this one-on-one after paying the deposit. Just check it out. And I'll see you all in the next session. Thanks everyone for joining, and take the code from GitHub, okay? Thanks everyone for joining.